So I'm having the students start here with graphing this line. Y equals -1/2 x plus 4. So Jack, where are you starting?
0, 4.
Yeah, you're starting at 4 on the y-axis. 0, 4. Very well said. And then you got to move somewhere. Wrecker, where are we going to move to?
Up to over one, left to the one.
That's an interesting way to do it. You might even be right, but I'm going to stick to a system that I always use. The top is the rise, and I always do the rise first.
Oh, so
But
down.
you're not necessarily wrong, but I'm going to start with rise of -1. Okay, and that means down 1. And then what?
Over 2 to the right.
You got it. So there's my new point. Okay, and let's just keep going with that until we end up hitting the x-axis. So would you agree that that is a linear equation? And so this is called linear programming. And the programming part is where you graph a few things together. And if this is going to be cars, and this is going to be buses, and we tell you that cars, this is a parking lot. You know, you go to a ball game and you got to pay like 20 bucks to park. Cars, you get 20 bucks. You are the person who's getting the 20 bucks because they're parking on your lawn. People do this by the state farm or by the state fair all the time. They rent out spots on their lawn. And some people make thousands of dollars. All they have to do is park cars on their lawn, and because they live by the state fairgrounds. And so for that 10 days of the state fair, they can make thousands of bucks parking people's cars. So a bus, though, would take up a ton of spaces. And so you're going to charge way more for a bus. Let's say that we charge $150 for a bus. Okay. Now, let's do the shading on this thing. I said less than. I'll now put it in there. Okay. Now, if I made another y equals equation, like, don't write this down. I'm just saying if. If I made another y equals equation like y equals 3x plus 1, and I did something like that, then you could find that point of intersection with the calculator. So I know you could do that. We just did something like that. Let's just see if it's still in your head, okay? Don't graph this one. I don't even need you to graph it. Because we don't want to try to find the answer by graphing it, because sometimes they come out not nice numbers like decimals. So instead, why don't you use your calculator to graph these two equations and do second calculate intersect. Now, the thing that I'm going to write up on the board here is second plus 7, 1, 2. Because it was literally like 5 times yesterday that kids had an unexplained weird thing happening on their calculator. They had gotten into a weird mode that didn't even know what they did. And to fix it, that's what I typed in the calculator. Second plus 7, 1, 2. So if your calculator's being weird and you can't graph, you're in some weird mode, just hit second key plus 7, 1, 2 and it'll clear it out. Now, for those that missed that day, I'm just going to be super brief. You better go watch that video. But we're putting this under the y equals on the calculator screen. You got to be careful that you use a negative key, not a minus key, on your 1/2. Another thing you'd want to do, in my opinion, I say to always put your fractions in parentheses, because otherwise the calculator might think it's -1 divided by 2x, which is a totally different thing. We want them to know it's -1/2, so I put parentheses around that. Again, I can't tell you that that'll always happen to you, but if you put parentheses around it, you're safe. All right. Would you please now, we're not going to do the push together into partner groups thing today, but we're just going to ask, would you just pull up your intersection point and compare it to the kid next to you? And if they don't know how to do it, please remind them it's under calculate, which is right above the trace button, okay? The trace button on near the top row of the buttons, there's this thing called calc right above the trace button, and then you want intersect. And then the weird thing at the end is you got to hit enter 3 times. And then it finally jumps to the spot where they intersect. Okay, check with the kid next to you, make sure you got your intersect point right. So by using the calculator, we were able to figure out that 0.857 and 3.57 were the coordinates of that point right there. Okay. Now, here's one that stumped a lot of people yesterday. What if it isn't something you can put in the calculator? Do you remember the kind where if I go straight up and down like this with a line, and let's say I shade this way, that is the line x is less than or equal to 4. How are you going to put that in the calculator? You can't, because the calculator says y equals y equals y equals, so you can't put in x equals 4. So how are you going to find that kind? Well, I'm going to simplify it for you. You have 2 equations to deal with then. You have y equals -1/2 x plus 4. And the other equation is x is less than or equal to 4. This could be done with algebra. And that is the only way that I know of that you could do that one. Okay? And other than looking on the graph, if your graph is accurate enough and you can just see where they cross, yay for you. Pretty much not going to happen on the test. They're not going to give you super easy intersection points. Okay, so first job doing this with algebra is to set them both as equals signs, because you want to see where they cross. And now this one is set up beautifully for something called substitution. The x is 4, and look, that's where x is, and so you just put in a 4. X is 4. Well, I'm going to put in x is 4. And now my equation is down to just y equals. And y equals -1/2 times 4, which is -2 plus 4. What's -2 plus 4? It's 2. So y equals 2. And what was x equal to? 4. So it's 4 comma 2. Missed the big ending there, Mr. Server. 4 comma 2. There we go. So moral of the story is, if you can't use the calculator to solve it, then there's always algebra. Okay. Now, there is 2 ways to solve. That was called substitution, and I want to remind you of another way. 2y plus x equals 7, and y minus 3x equals, well, let me just make it, I'm not going to make it work nice. I'm going to make it not work nice. That's fine. I'm going to remind you how elimination works. Right now, if I were to add these together, straight down, straight down, straight down, does anything drop out? Does like x drop out or does y drop out? Nope. So we got to do something to it first to make it drop out. Do you see that it would be pretty slick to multiply the top one by 3? I want you to process that for a second to get why I would like multiplying the top one by 3. Because now the 3x and the negative 3x drop out. Cool. Was there another way you could have done that? Absolutely. Instead of multiplying the top one by 3, I could have multiplied the bottom one by something. Please talk to the kid next to you about what you could have multiplied the bottom equation by. And I heard two kinds of people there. I heard people say 2, and I heard people say negative 2. What do you think the actual right answer is? Multiply by? Negative 2. And that matters. Like, obviously, there's a big difference between those two. And the reason is, when they put 2y and negative 2y together, they cancel. But 2y and regular 2y, that would make 4y. All right, so I'm multiplying everything by negative 2. I'd like you to finish this one and just try to figure out what the final answer is with algebra. You will be graded on this on the test. If you're thinking, well, I'll just use a calculator to graph these, see where they cross, and I'll do the intersect thing. Nope. You have to do sum by algebra. We're going to say right on the test. Have to show algebraic steps. Yes?
Does that mean you can just do substitution?
Yes, you're allowed. We're not going to force you to do elimination. But I'm telling you, pro tip, way easier to do this. This is the elimination method. I'm telling you, it's way easier. Now, there's sometimes where substitution is better. That's why it's good to have both tools. You know what I mean? Like sometimes you'll be able to see, oh, substitution, I'm going to substitute this. It'll be super quick and easy. Other times, elimination is the best tool, like in this case. All right, so x, and that makes positive 6x, makes 7x equals, and then negative 20 and 7 makes makes negative 13. Divided by 7, divided by 7. Did you guys get negative 13 sevenths? Yes? All right, good. Now that's a decimal, and it's not illegal to use a calculator to get your decimal for that. I mean, you're going to have one on the test, and that's not cheating with algebra. That's just dividing two numbers. Yes, question?
Can you also give them in the y-intercept form and then make them like equal using that?
You can solve them both for y first if you want to. Yes. The answer is going to come out the same either way. And so you're right. Solving it for y would totally work. But I would submit that's going to take you about 3 steps on each equation just to get them solved for y. All right. So again, this method of solving is not required. But knowing how to solve it with one of the methods is required. All right. So what is 13 divided by 7? 1.8571. And it's since I can't tell because I used a phone, does that go on and on and on? Or is it actually stop there? It keeps going? All right. So then I have to decide like how far is enough. And it would kind of depend on what they asked for rounding on this. But I'm going to assume that they're only going to want it rounded to like 2 places. So I'm going to round to 3 places because I'm in the middle of the problem. And then I just have to go put it back in. If x is negative 1.857, then here's my equation right there. And so I would start by adding 1.857 to both sides. What is 7? Oh, I can do that in my head. I'm adding 1.857. So now I got 2y equals, nope. I subtracted, what am I doing? No, I got it. I'm adding 1.857 to both sides. And now I've got 8.857. And then I'm going to divide by 2, divide by 2. What is 8.857 divided by 2?
8.857 divided by 2 is 4.4285.
4.4285. And if I end up rounding to 2 decimal places, I got my x as 1.86 and my y as 4.43. Look, I didn't graph and see where they crossed, and I showed my algebraic steps. Now, let me talk about this. You'll have the calculator. Is there any way I can stop you from graphing both of them and seeing where they cross? No, you can totally do that. It's just if you don't show me your work and all you have is magically this answer appears, I know that you used the calculator to get it. So it's not illegal to check your answer, but to do that, you'd have to solve them both for y. So you're going to end up with a whole bunch of extra steps to solve them for y and then put them in your calculator and graph them and see where they cross. But you have to know how to solve it with substitution or elimination. And I know that's, that's kind of cruel because you have a calculator, but this is one of the most important algebraic things you've got to learn to do. And so as my job as an Algebra 2 teacher is make sure you know how to do it. So it's so important that I made a worksheet, and that's one of our main jobs for today. It's literally only got 4 questions on it. But the worksheet has an example of substitution and an example of elimination, and it's got 4 questions. So that's just the reminder, you got to know how to do it by hand, all right? So that's part of your homework for today. So I'm actually going to hand that out at this point. I'm going to pause the video. Okay, so we did the worksheet called Systems of Equations, and we just did problems 1 and 3, and pretty much everybody got them right. Yay. Okay, awesome. You got that part down. Next part is, do you even know how to optimize? So I'm going to give you a graph like we will sometimes on the test, where it's like, I don't even care if you can graph right this second. I just want to know if you can optimize. Let's say that in the end, it was that feasible region right there. So these are obviously the key points. And in case you're having trouble reading them, that one's at 3. I'm going to say this one is a point right there at 3, 2. And this one's at 1, 2, 3, 4, 5. I'm intentionally being a little vague. This one's 0, 0, of course, so we can just ignore that one. Now, X is going to be where you can stick to the cars, buses thing. So, let's say in this situation, cars are worth more for some reason. Okay, not sure, think of a situation right this second where cars would be more profitable than buses. What would be a situation like that? Because buses are bigger, so usually they would cost more. If you could think of a good, real world scenario, that'd be awesome. But let's say for cars, they're going to be $30. And let's say for buses, they're going to be $5. For some reason, you really want to incentivize cars to come to your place versus buses. Or maybe it's the cost of something. What would cost more on a car than it would on a bus? Anyway, I want to make cars more because of the graph, because it'll make it more interesting. So then how would you write the optimize equation for this? This is profit. You're going to make $30 profit for the cars and $5 profit for the buses. How would you write the optimize equation? And then, how would you show that a certain point is the best? All right, let's see if you know how to do that part of these problems. What is the optimize equation? Before we go too far, I just want you to check your optimize equation with the kid next to you. Make sure that they have an actual equation. It has to have an equal sign. And then, after you've checked that with them, you have to show a comparison of all of the corners. So you got to figure out the answer for this corner, this corner, this corner. The only corner you don't have to do, what did I say before? 0, 0. So you got to show what you got for profit on all 3 corners. And then, of course, the answer becomes obvious. If it's profit, you want the most profit you can. All right, I'm going to pause for a second while you optimize this problem. Okay, for this part of these problems, you would have to go P for profit equals, and again, technically the variable doesn't matter. You just can't pick X or Y. The X usually goes first, but technically it doesn't have to. 30X plus 5Y. And then a way to stay organized would be to write out each point. I have no strict rules on how you write out the points, but I'm going to do them like this. 0, 5 is one of my points. 3, 2 is one of my points. And 3, 0 is one of my points. Now I totally would get, if you're just thinking at all, you know 3, 2 is going to be better than 3, 0. Okay, I get it. But I still need you to test all of the points except 0, 0. Okay? Every now and then you mess up by not testing one of them because you forget, oh, wait a minute, they wanted me to minimize on this problem. I want the smallest answer, you know? And on profit, of course, you want the biggest answer. But all right, so Sophie, what'd you get for 0, 5? 25 is correct. What did you get for 3, 2? Let's go with Jack.
I got
100 even? Okay. And Sadie Lindemann, 3, 0.
Yeah, 15.
What?
Oh, I did it backwards.
Oh, okay. 3 is the X, and so I'm going to put the 3 right there. And then they got 30 times 3. I think it's 90. Can anybody verify 90? All right, good. So then you can tell which one's the biggest. Hanson, what wins?
3 and 2.
Yeah, 3, 2 gets you the most profit. There you go. All right, so that's that part of the problem. Then I'd say the scariest part that's left is the writing out the equations for them. So let's just do one like that, where I tell you the story. You have to write out the equations. Okay? Let's do one that's a nice, normal, real-life situation. You guys know a lot of times that at a there's tickets, and you know that there's different ticket prices when you go to a concert. If you're up close, you pay way more than if you're like out in the back. And in fact, there's tons of different prices, but we're just going to keep it simple. We're going to say there's the front row, and they're going to pay way more, and then there's the other seats. Okay, so front row seats are going to be $50, and the others are going to be $20. So you have the concert. And you make $2,040. Can you tell for sure how many front row seats versus other seats were sold? No, you can't. All right. But you can write an equation for it. It's just that the equation has lots of different possibilities. Until we get 2 equations, you won't be able to actually answer the question. But what equation can you write so far? Now, let's call the front row X. You actually could have picked either one, but to make us all be the same, let's choose front row is X, and the other ones are Y. All right. Please talk to the kid next to you. What is that equation? All right. So now, let's say that we know how many people total attended the concert. If I said 10 people attended the concert, do you get how that's probably not possible? All right. Let's go with 90 people attended the concert. Well, that's another equation, right? Arlo, what's the equation then if 90 people attend?
X plus Y is 90.
Yeah. And the other equation I should write right above it would be 50x plus 20y was equal to 2040. Now, would you have to use a calculator to solve this problem? No. You could do it with algebra. I just showed you how to do it with algebra, right? And in fact, this is a really good one for elimination. Take a second. Figure out what to multiply something by. And do it with elimination. All right, I'm curious because I want to do it the way that most people did it. Who multiplied the bottom by negative 50? Raise your hand if you did it that way. Not many. All right, who did multiply the bottom by negative 20? Good call. Why? Because it's just the numbers are smaller. What is 2040 minus 1800?
2040 minus 1800 is 240.
What is that divided by 30? Well, look at that. It worked out to a nice number. Who got x equals 8? Nice. Now, technically, what's wrong with what I just said? Not that x equals 8 is wrong. It's just I'm implying that that's the answer. Why is it not the answer? If you leave it like that, you're toast. You get it wrong. It's just a little thing. Come on, somebody knows. You know, Morgan?
I need to figure out why.
Yes, you still got to figure out why. You can't just leave the answer with just x. All right. So I got x, that's cool, but I don't know why now. So now I go back to my original equation, which was that x plus y equaled 90. And if x is 8, x was the front row seats. Apparently they sold 8 front row seats. That must mean they sold 82 of the other ones, right? So the answer is actually 8, 82. I think. Verifying with Hansen. Is that what you got too? All right. Awesome. Cool. So now you need to actually try the whole problem from start to finish. You write the equations, you graph the equations, you find where those key spots are on the feasible region. So again, you write the equations, you graph them, it looks like this and this. You shade the right way, which isn't always that way, by the way. Sometimes if you're shading above both of these lines, do you get that it would actually look like that? You never go into the negatives. Those are called the real world constraints. So the y-axis is this line right here. And so it'd be x is greater than or equal to 0 as on every graph. And this is the x-axis, so it's y is greater than or equal to 0. So we're always going to shade up. But sometimes it's like the green one, and sometimes it's like the red one. It just depends on which way you shade on your lines. All right. But the corners are super important, the corners of the feasible region. And then you test them with the optimization part. All right. Now we've gone over every single thing. And in theory, you could take the test tomorrow and probably most of you would be okay. Okay. But tomorrow we're just going to review some more and make sure you've had plenty of chances to ask questions. And then we'll take the real thing on Monday. All right. So this is the part where I've got a review worksheet queued up for you. If you go on to Schoology and find that, you're going to see a review worksheet there. Let's open it together and talk through which ones I would recommend you might want to skip. It's called Linear Programming Review 1. Given that I'm kind of went long today, we are going to do number 1 for sure, and then I want to look closer at what's better to skip 2 or 3, but why don't you all just start with number 1. I figured it out. We're doing problems 1 and 2 on this worksheet and skipping number 3. Okay? All right. If you would like graph paper to actually be able to graph better, I'm going to hand out a piece of physical graph paper to all of you because that's how you have to do it on the test. You're not going to be doing it on your computer and you can't hand in your little TI-84 screen, right? So I think it'd be smart to do the graphing on graph paper. So I'm going to hand that out to you now. And that's all I got for you for today.